feedback as to what types of nozzles and where, and maybe they can configure the nozzle locations and things like that, which is typical. Then we've got a set of questions here to show what Flex 3D is about. I'm going to run Flex 3D, different sets of content options. So I'm going to create some 2D drawings, and then I'm going to create a 3D stereolithography file, which is used for different types of 3D prototyping. Then I'm going to hit the continue button. At this point, the configurator is processing the rules, processing the configured components. It's going to extract the 3D data that needs to be passed over to. Now this might go by too fast to see, but we'll see if you can screen running here. Well, it's already made the model assembly. The 2D drawings are coming out. It's actually completed the whole assembly. Now I'm going to stop afterwards and actually walk through the assembly so you can see it, so we won't have to worry about screen refresh. In other words, I can stop it. Well, let's go back and change something here. Back to the beginning here, I'm going to change the plate count to 20. I'm going to say that really I want to have front and back nozzles. I'm going to change it to 4 tabs. Now it's going to ask me to supply information for the additional nozzles. First, we got to wait for your screen to refresh. So now let's say I'm going to put a socket weld on the 3rd nozzle, 1 5/8. On the 4th nozzle, socket weld, 1 5/8. That's going to regenerate the 2D model. I've got a front plate. If I look on the back plate, I should also see 2 nozzles on the bottom because I put 2 on the top of the front and 2 on the bottom. So now I'm going to run Flex 3D again. I'm going to create drawings. I'm going to make an ASYS file, 3D stereolithography file. I'm going to hit continue. At this point, it's grabbing all the component information, passing over to the 3D server. I'm running in queued mode. We'll talk about that in a second. In other words, I'm queuing the job to a content service that then grabs all the data and passes it off to Pro.
Have you done any testing with SolidWorks on this?
Well, we'll get to that in the end. So you can probably see some things come by. It just depends how fast the refresh is. So essentially, we made a 3D assembly based on the configuration, etc. So now I'm going to get out and we're going to walk through it so you can actually see the stuff. I can stop it. So we have various applications that allow us to support the different parts of the design process. For example, if I was a CAD model designer, I would like to be able to run configuration sessions and then step through the 3D Flex 3D portion and see what the models are doing. So we have something called a simulator, and we have various simulators, 2D simulators, 3D simulators, translation simulators, etc. But I can, even on this same machine, I can initialize this simulator. I can attach to the Flex 3D server that's running. And what that does is essentially then attaches to the running Pro-E session. And then we have basically a job file that was processed. This is how we transferred the data. And let's get the one that we just ran. So 1225, it's right here. So this is the file we just got through processing. So now basically what I can do is step through the automation process and test and validate it. This is not done by an end user. This is not done by a configurator user. This is done by people internal to your organization who work with Flex 3D and create models. So loading a start model. The concept is a start model is nothing but an empty assembly. So if I go back to the Pro-E session over here, now in this Pro-E session, basically I'm going to switch back over here. All we've got is a start part, which is nothing but a set of datums and a coordinate system. So an empty assembly at this point. So now if we said load the same components that we just did via the configurator, we're going to load some components into memory. We're going to assemble those subcomponents. come back over here. You'll notice when I bring that assembly up that things are in the wrong spots and wrong sizes. For example, you'll notice one of the nozzles is real small in the wrong spots because these parts were just loaded off the disc. In other words, this is a new assembly. So until we actually say regenerate those components and pass the configurator information to them, they don't know what size to be. So now at this point, we've regenerated the assembly. And you'll see it looks correct. It's the last one I just ran. It's got two nozzles on the front. See if I can spin it here. It's got two nozzles on the back. Different types of NPT on the front, socket weld on the back. If I look at this assembly tree over here, all these components were just added on the fly and added to that assembly. Then the configurator parameters were passed down. We regenerated the assembly, made the content, etc. So this is what was going on behind the scenes and happened kind of too fast for you to see it all. There's also things like bill of material behind the scenes. So we can grab the bill of material information. Won't get too deep into it, but here's the whole product structure. There's a brace pack, there's a front, there's a whole bunch of plates there and all that other good stuff. So we know the parent-child relationships and can pass manufacturing information to and from the assembly back and forth to Flex 3D and the configurator. So that's how that dynamic assembly got built on the fly. A couple more things. I'm going to get out of here. There's another simulator I'm going to show you briefly. I'm not going to talk about it too much, but just kind of walk you through something. Happen to have AutoCAD running here. Now, one of the things that we do with a module called Flex Translation, it's a new module that we're just completing the integration to. We've had the technology for quite a few years, but we're integrating it right into the Flex 3D layer in the configurator. This allows us to take content that we've created in Flex 3D and post-process it so that it can be used in AutoCAD or other CAD applications and build what's known as intelligent blocks with attributes and all those good things. So I'm going to load another translator here. And I'm going to attach to essentially the AutoCAD server. Now there's a whole bunch of setup parameters that drive the content, layer names and text heights and attribute styles, all these things that if you're an AutoCAD person you would know about. But I'm just going to run that same piece of content through this translator and show you what happens. So first of all, I'm going to do a content request. We just got through making something called 422 SAT. That is an ACES file. I'm going to make a file called 422demo.dwg. Let's switch content type. And essentially, I could pass attributes and all that good stuff, but let's just go ahead and do this. At this point, we're going to translate that 3D ACES file into an AutoCAD block. And see if we can refresh here so you can see it happen. Wait 1 second. Essentially, now we're using Flex Translation to drive an AutoCAD process. It's going to go in, load a 3D assembly, build a new piece of content into a brand new AutoCAD block. I can go ahead and do something called insert. That's not what I want to do. Let me see. There we go. Just got through making this 422 demo right here. I'm going to insert this as a block into AutoCAD. I'm going to change some view things around so you can see what I'm doing. That 3D block was just created by the Flex Translation module, which allowed us to take that Flex 3D content that originated in Pro-E, translated it into AutoCAD format, turned it into a block, put attributes with it and all that good stuff. And it's full 3D content. I'll refresh it so you can see it here. It's that same exact model that you just got through seeing inside of Pro-E. So this is